Sixth question. Find the area of the region in the first quadrant enclosed by x-axis. Line x is equal to root 3y and the circle x square plus y square is equal to 4. So here we have a circle x square plus y square is equal to 4, and this we can write it as x square plus y square is equal to 2 square. X square plus y square is equal to 2 square, and this is a circle with the center, origin and radius 2. X square plus y square is equal to 2 square is a circle with the center, origin and radius 2. So we will draw one circle. Okay, this is our circle. Since it is a circle with a radius 2, this point that is 2, 0, and this is minus 2, 0, 0, 2, 0, minus 2. Now we have a line x is equal to root 3y. If you put x is equal to 0, you will get y is equal to 0. If you put x is equal to 0 here, you will get y also equal to 0. That means this is a line which passes through the center or origin. Okay, this is a line which passes through the origin. So this is our x is equal to root 3y. Now we need to find the area of the region in the first quadrant. So it is enough to consider a figure in first quadrant enclosed by x-axis, line and circle. That means our shaded region boundaries we need to get as x-axis, line and circle. So in first quadrant we have two portions. Suppose this is first portion and this is second portion. Just look at your first portion. One boundary is circle, the next one is line, and this is your y-axis. Okay, this is your y-axis, but we need to get the boundary as x-axis, not y-axis. So the required region is actually the second portion. Okay, this is our required region. Now we are going to find the point of intersection. Okay, this point is actually the point of intersection of the circle and the line. That point is actually the point of intersection of the circle and the line. So that we are going to find. Suppose this is equation number 1. Here we have x is equal to root 3y. Now equation number 1 implies instead of x I am going to substitute root 3y. So root 3y all square plus y square is equal to 4, or 3y square plus y square is equal to 4. 4y square is equal to 4. Y square is equal to 1 implies y is equal to plus or minus 1. Y is equal to plus or minus 1. Since this point of intersection, that is B, lies in the first quadrant, it is enough to choose y is equal to positive 1. So if y is equal to positive 1, y is equal to plus 1, then x is equal to root 3 into 1 is equal to root 3. So the coordinate of the point B, that is root 3 comma 1. The coordinate of the point B, that is root 3 comma 1. Right. Now I am going to draw one line through that B. Since the x coordinate of this B is root 3, that means that line will intersect our x-axis at root 3. Okay, I am going to draw one line which is perpendicular to x-axis through that B, and the x coordinate of B that we know, that is root 3. That means that line will intersect our x-axis at root 3. Now just look at this figure. This we can divide, let it be C. The shaded region we can consider it as sum of two regions, that is OCB plus ABC. OCB plus ABC. We can consider that shaded region as the sum of two regions, that is OCB plus ABC. Now we are going to find out the area of the shaded region OCB. Area of the shaded region OCB. Just look at this OCB. OCBO. Okay. OCBO. Just look at that portion. Here the value of x, that is 0, and here the value of x, that is root 3. That means in that region x varies from 0 to root 3. X varies from 0 to root 3. And in the region ABCA, this is the starting point, and the value of x there, that is root 3, and at A the value of x is 2. So in the first region x varies from 0 to root 3, and in the second region x varies from root 3 to 2. Since we took the variations of x, we need to write our equations as y is equal to. Now just look at the first portion, OCBO. Just look at the first portion, OCBO. OC, that is our x-axis, BC, that is our line, and BO or OB, that is our line x is equal to root 3y. There is no part of a circle we have. In boundary, there is no circle parts. Okay, circle is not there in OCBO as a boundary. Here the boundaries are OC, that is x-axis, and BC, that is our line x is equal to root 3, and OB, that is our given line x is equal to root 3y. Okay, this is actually the area under the line x is equal to root 3y. The OCBO, that is the area under the line x is equal to root 3y. From here we will get y is equal to x by root 3. Y is equal to x by root 3. Now just look at the second portion, ABCA. ABCA, x is equal to root 3, and AC, that is by x-axis, and AB, that is the part of the circle. So in that region our boundaries are x-axis and the line x is equal to root 3 and circle. Okay, so the second portion is actually area under the circle, x square plus y square is equal to 4. Area under the circle, x square plus y square is equal to 4. Okay, because in that portion, in our boundaries, we have the circle. We don't have the part of the straight line x is equal to root 3y. From here, we will get y square is equal to 2 square minus x square, or y is equal to root of 2 square minus x square. Y is equal to root of 2 square minus x square. Now we are going to find out the area of the required region, or area of the shaded region. That is, the first region x varies from 0 to root 3, and the value of y, that is x by root 3 into dx, plus in second region x varies from root 3 to 2, the y value is square root of 2 square minus x square into dx. Integral 0 to root 3 x by root 3 dx plus integral root 3 to 2 square root of 2 square minus x square dx. First one, this 1 by 3 is a constant, we can take it outside, and the integral of x is x square by 2 from 0 to root 3. And the second integral, that is of the form integral square root of a square minus x square. Integral square root of a square minus x square, and we know that this integral square root of a square minus x square is a square by 2 sin inverse x by 2 plus x by 2 square root of a square minus x square. This is a square by 2, that is 2 square by 2 sin inverse x by 2 plus x by 2 into square root of a square minus x square from root 3 to 2. From root 3 to 2. Now we need to give upper limit and lower limit. Now we need to substitute the value of upper limit and lower limit. So the first one, 1 by root 3 into, if I substitute root 3, I will get root 3 square, and we know that this root 3 square is 3, so 3 by 2 minus 0, plus, now we need to apply 2, so that is 2 square is 4, 4 by 2 is 2, So 2 sine inverse, the value of x is 2. 2 by 2 plus 2 by 2 square root of 2 square minus 2 square. Since x is 2, we will have 2 square minus 2 square minus, now just substitute the lower limit. 2 square is 4, 4 by 2 is 2. 2 sine inverse root 3 by 2 plus root 3 by 2 into square root of 2 square minus root 3 square. 2 square minus root 3 square. Now this is equal to 1 by 3 into 3 by 2. 1 by 3 into 3 by 2, that we can write it as root 3 by 2 plus 2 into sine inverse 1 we will have. Okay, 2 into sine inverse 1. The second term 2 square minus 2 square 4 square minus 4 minus 4, that is 0. 0 into 1, that is again 0. That term become 0. So no need to consider that part. So sine inverse 1 minus, now 2 sine inverse root 3 by 2. 2 sine inverse root 3 by 2 plus root 3 by 2 into 2 square is 4, root 3 square is 3. So 4 minus 3 is 1. Root 1 is 1 itself. Root 1 is 1 itself. Now we need to simplify it. This is equal to root 3 by 2 plus sine inverse 1, that we know, that is pi by 2. So 2 into pi by 2 minus, just open this bracket, 2 into sine inverse root 3 by 2 is pi by 3. Pi by 3 minus root 3 by 2. I just open this bracket and I substitute that sine inverse root 3 by 2 as pi by 3. Root 3 by 2 minus root 3 by 2 get cancelled. 2 get cancelled and we will have pi minus 2 pi by 3. That is equal to pi by 3 square units. So the area of the shaded region is equal to pi by 3 square units. Now seventh question. Seventh question also we have one circle. Find the area of the smaller part of the circle. X square plus y square is equal to a square, cut off by the line x is equal to a by root 2. So here the equation of the circle, that is x square plus y square is equal to a square. X square plus y square is equal to a square. This is a circle with center, origin and radius a. Okay, this is a circle with a center, origin and radius a. Okay, now just draw one line and draw one circle. Okay, this is our circle with a center, origin and radius a. Since the radius is a, then this point is a comma 0. That point is a comma 0. Now x is equal to a by root 2. X is equal to a by root 2, that is our line. Anyway, we know that this a by root 2 is less than a. A by root 2 is less than a. Since this point is a, then a by root 2 will come somewhere here, right? And a by root 2 is positive because a is positive. And thus a by root 2 is obviously less than a. So that point a by root 2 lies in the positive x-axis. And it is less than a. So we can take that a by root 2 somewhere here. A by root 2 which is lies in between 0 and a. Now x is equal to a by root 2 is a line which passes through a by root 2. This is our line x is equal to a by root 2. X is equal to a by root 2 is a line which passes through the point a by root 2 and parallel to y-axis. Now we need to find out the area of the smaller part of the circle. Area of the smaller part of the circle. Now just look at this figure. Anyway, this part is bigger than this part. So the smaller part is, this is our smaller part of the circle. Okay, that is our smaller part of the circle. Now we need to find out the area of that shaded region. Just look at that figure. We can see that in the first quadrant and the second quadrant we have same area. In the first quadrant and the second quadrant we have same area. So it is enough to calculate that area in the first quadrant. 2 into area in the first quadrant will give the area of that shaded region. 2 into area in the first quadrant will give the area of the shaded region. Now x square plus y square is equal to a square. Then y square is equal to a square minus x square. And y is equal to square root of a square minus x square. And the variation of x in that region, here we have a by 2 and plus we have a. So the variation of x is from a by root 2 to a by root 2 to a. So the area is equal to 2 into area of ABC. 2 into area of ABC, that is 2 into integral a by root 2 to a square root of a square minus x square into dx. 2 into integral a by root 2 to a square root of a square minus x square dx. We can directly apply the result, that is equal to 2 into a square by 2 sin inverse x by 2 plus x by 2 square root of a square minus x square from a by root 2 to a. From a by root 2 to a. Now we will apply upper limit and lower limit. So that is equal to 2 into upper limit is a, so just put x is equal to a. So a square by 2 sin inverse a by 2 plus a by 2 square root of a square minus a square minus, now a by root 2 we need to substitute, that is a square by 2 sin inverse a by root 2 by 2 plus a by root 2 by 2 into square root of a square minus a by root 2 all square. A square minus a by root 2 all square. Now we need to simplify it. Here we have a square minus a square, that we know this a square minus a square is a square minus a square, that we will get it as 0. Okay, this is actually x by a, this is actually x by a, this is also a we will have. Now this is equal to 2 into a square by 2 sin inverse 1. Okay, a square by 2 sin inverse 1. The second term, that is become 0, minus of a square by 2. A get cancelled and we will have sin inverse 1 by 2. 1 by root 2. Sin inverse 1 by root 2 plus a by root 2 by 2. A by root 2 by 2 we have, that we will write a by 2 root 2 into square root of a square minus a square by 2 we will have. A square minus a square by 2 we will get. Now this is equal to 2 into a square by 2 sin inverse 1 is pi by 2 minus, just open this bracket, a square by 2 sin inverse 1 by root 2, that is pi by 4, minus a by 2 root 2. Just take LCM inside the square root, then 2a square minus a square by 2 we will get. 2a square minus a square is a square. So we will get square root of a square by 2. A square by 2. And this is equal to 2 into a square pi by 4. A square pi by 4 minus a square pi by 8, a square pi by 4 minus a square pi by 8, and this is minus a square, we can take it outside of square root, then that is becoming a into a square divided by root 2 into root 2, that is 2, so a square by 4 we will get, right. Now this is equal to 2 into 2 by 2 into, in first term and the second term, a square pi by 4 is common. The first term and the second term, a square pi by 4 is common. Just take it outside. A square pi by 4 is common. Just take it outside. Then in the first term 1 will remain, and the second term 1 by 2 will remain. Minus a square by 4. And this is equal to 2 into a square pi by 4. A square pi by 4. 1 minus 1 by 2 is 1 by 2. 1 by 2 minus a square by 4. Now just open the bracket. Then we will get a square pi by 4. 2 into 1 by 2 get cancelled. Minus 2 into a square by 4 is a square by 2. So a square by 2 we can take it outside. Then pi by 2 minus 1 we will get. So the final answer is a square by a by 2, a square by 2 into pi by 2 minus 1. A square by 2 into pi by 2 minus 1 square units. Now 8th question. The area between x is equal to y square. The area between x is equal to y square. 8th question. X is equal to y square and x is equal to 4 is divided into two equal parts by the line x is equal to a. Find the value of a. Find the value of a. X is equal to y square, that is a parabola open in the positive direction of x-axis. X is equal to y square is a parabola that is open in the positive direction of y-axis. Okay, this is our x is equal to 4, and the line x is equal to a. Divide this region into two equal parts. Divide this region into two equal parts. Then we need to find out the value of a, right? We need to find out the value of a. Can you please tell me, in that shaded region, x varies from, in that shaded region, x varies from 0 to 4. In that shaded region, x varies from 0 to 4. This is our region, and this x is equal to a. Divide this region into two equal parts. Now area O A D E B C F. So x is equal to a is actually dividing the area bounded by the parabola, and x is equal to 4 into 4 equal parts actually. Okay, it is dividing into that shaded region, that x is equal to a. Divide that into 4 equal parts actually. So area of OAD is equal to area of AB, area of OAD is equal to area of ABCD, area of ABCD, or thus we can write it as area of OED is equal to area of EFDC, right? EFCD. Thus x is equal to A, that is dividing our area into two equal parts. That means OAD, that area, and ABCD, that area, they are equal. But in first quadrant and the fourth quadrant, we have same area. The area in the first quadrant is equal to area in the fourth quadrant because that parabola is symmetrical about x-axis. So it is enough to consider area in the first quadrant. It is enough to consider area in the first quadrant. That is area in the first quadrant. In the first part is OED. And in the second part is EFCD. Okay, actually they are also equal because this x is equal to a divide our area into equal parts. Now in this region, the first region x varies from 0 to a. The first region, that is in OED, x varies from 0 to a. And in the second region, x varies from 0 to a. And the second region, x varies from, second region, that is a EFCD. EFCD, x varies from a to 4. X varies from a to 4. Now, on both cases, the boundary, that is our parabola, x is equal to y square, and from here we will get y is equal to root x. X is equal to y square, from there we will get y is equal to root x. Now, since area of OED is equal to area of EFCD, that is integral 0 to a root x dx is equal to integral a to 4 root x dx. Integral 0 to a root x dx is equal to integral a to 4 root x dx. By using this relation, we need to find out the value of a. 0 to a root x. The integral of root x is 2 by 3 x raised to 3 by 2 from 0 to a plus 2 by 3 x raised to 3 by 2 from a to 4 equal to 2 by 3 x raised to 3 by 2 from 0 to a equal to 2 by 3 x raised to 3 by 2 from a to 4. Now, if you substitute the lower limit, this is become 0 in LHS. So in LHS we will get 2 by 3 a raised to 3 by 2. 2 by 3 a raised to 3 by 2 is equal to, here we will get 2 by 3 is a constant. We can take it outside and we need to substitute the upper limit. So 4 raised to 3 by 2 minus a raised to 3 by 2 we will get. And this is equal to 2 by 3 into 4 raised to 3 by 2, that we can write it as 4 raised to 1 by 2 all cube. 4 raised to 1 by 2 is 2. 2 cube is 8. 8 minus a raised to 3 by 2. 8 minus a raised to 3 by 2, or thus we can write it as 16 by 3 minus 2 by 3 a raised to 3 by 2. 16 by 3 minus 2 by 3 a raised to 3 by 2. That means we got 2 by 3 a raised to 3 by 2 is equal to 16 by 3 minus 2 by 3 a raised to 3 by 2. Okay, now just take that 2 by 3 a raised to 3 by 2 into LHS. So that is 2 by 3 a raised to 3 by 2 plus 2 by 3 a raised to 3 by 2 is equal to 16 by 3. This is 4 by 3 a raised to 3 by 2 is equal to 16 by 3, and we will get a raised to 3 by 2 equal to 4. A raised to 3 by 2 equal to 4 we will get. Actually we need to find out the value of a, and here we got it as a raised to 3 by 2 equal to 4. A raised to 3 by 2 equal to 4. Now I'm going to take square on both sides. Just square on both sides. Then a raised to 3 by 2 all square is equal to 4 square. That is 2 get cancelled. A cube is equal to 16. Now take cube root on both sides. Then a is equal to 16 raised to 1 by 3. A is equal to 16 raised to 1 by 3. The 16 raised to 1 by 3, thus we can write it as 4 square raised to 1 by 3 or 4 raised to 2 by 3. So the value of A, that is equal to 4 raised to 2 by 3. 11th question. Find the area of the region bounded by the curve y square is equal to 4x and the line x is equal to 3. Y square is equal to 4x and the line x is equal to 3. Okay. So that is also a parabola open in the positive direction of x-axis. X is equal to 3. So this is our portion. So that is actually in the first quadrant and the fourth quadrant we have equal areas. So the required area we will get it as 2 into area in the first quadrant. 2 into area in the first quadrant. And here the x varies from 0 to 3. And the given equation is y square is equal to 4x. Then y is equal to root 4x is equal to 2 root x. Y is equal to root 4x is equal to 2 root x we will get. So here 2 root x dx. 2 root x dx. And that is equal to 2 is a constant. We can take it outside. And the integral of root x is x raised to 2 by 3. X raised to 3 by 2 divided by 3 by 2 from 0 to 3. And this is equal to that 3 by 2 reciprocal. Just take the reciprocal and take it outside. Then we will have 4 by. Okay, here 1 2 is there. Then that 2 and this 2 become 4. And this is 8 by 3. 8 by 3. And now we need to apply the upper limit and the lower limit. Then 3 raised to 3 by 2. If you apply the lower limit, that is become 0. So 8 by 3. And this 3 raised to 3 by 2. First we will take 3 cube. 3 cube all raised to 1 by 2. And that is equal to 8 by 3 into 3 cube is 27. Root 27 we will have. And this root 27 we can write it as root of 9 into 3. That is 9, we can take it outside of the root. Then that is become 3. Then 8 by 3 into 3 root 3. That is 8 root 3. So the area of the shaded region is 8 root 3 square units.